Good evening, all, and let's try this dangerous problem from indefinite integration. Usually, this problem is asked repeatedly in most of the test series conducted by these coaching institutes. This question was originally probably taken from a mathematical magazine. So let's talk about this. X square plus 6 divided by x cos x minus 3 sin x whole square. So of course the point is not just to solve the problem but also to motivate ourselves, like how to think for this problem solving, right? So one way of probably starting with will be, because there is almost no hope for the substitution much, because we have a species algebra and then trigonometry, as you can see in the denominator, and then we have algebraic thing. So the only hope probably will be integration by parts, such that if you take something u integration of b by parts, we expect u integral of b minus u dash into integral of b dx. So with this usual typical integration by parts formula, maybe this will give birth to two kind of expressions, and our expectation is the integration of the tougher expression will just cancel out of the picture and we're left with some answer. So before I go and give you the actual motivation for this problem, let's solve this in a very unconventional way. And here we go with that. To bring trigonometry into pictures, I'll write x square plus 6 into sin square x plus cos square x divided by x cos x minus 3 sin x whole square dx. And now very surprisingly, what I'm going to do is to convert this numerator into determinant so as to get the hint of x cos x minus 3 sin x kind of expansion. So x square plus 6, let's wait for that. Sin square x plus cos square x reminds me of a famous rotation theorem that gives cos x sin x and minus sin x cos x. So it's a way to split this expression. Now x square plus 6, if you want to express, because minus 3 is a motivation, so somewhere we need to bring 3 or minus 3. So it can be done with x and x. And either I can come with minus 2 or 3, or I can come with minus 3 or 2. So both combination we can try until we see some motivation of bringing, x cos x minus 3 sin x whole square in denominator. And you'll see in a very cool way, the denominator gets into the structure of integral. Now first row I'm going to multiply with first column according to law of multiplication determinant. Here you can do it any ways. So we'll have x cos x minus 3 sin x. Similarly, x sin x plus 3 cos x minus 2 cos x minus x sin x, and we have minus 2 sin x plus x cos x. So the given expression can be fashioned in this form with x cos x minus 3 sin x whole square. That gives a bit motivation of putting this into multiplication, and you can see x cos x minus 3 sin x came into picture, and because of that probably here we have kept 3 and x, so that cos x and minus sin x bring that structure. And now this can be beautifully written as this into this minus this into this, so x cos x minus 3 sin x times x cos x minus 2 sin x divided by x cos x minus 3 sin x whole square, and we'll have minus times x sin x plus 3 cos x into minus of this, so that clearly gives plus of 2 cos x plus x sin x divided by x cos x minus 3 sin x whole square. With this motivation into picture, we can cancel x cos x minus 3 sin x here. So the given integration is just left to integral of this divided by integration of this, right? So I hope till here all of you got this manipulation. Of course, like the manipulation of thinking determinant was completely off track, but let's see how to deal with this before I give you actual motivation of how to think for this problem. So now what I'll do is x cos x sin x and plus 3 cos x is there, and we have something cos x plus x sin x. So I can use integration by parts on this heavier integral so as to bring maybe negative of this integration into picture, right? So if maybe after solving up of this interval, if somehow I can bring the negative of this, let's call this integral as some I1. Clearly I'm not taking care of constant, this is I2. So target is if somehow I can bring I2 as minus I1 plus something, and then I1 plus I2 is definitely that has, so I1 will get kicked in the process, and that's a very typical integration by cancellation logic, right? So for that it's not very clear still like how we are going to approach, but we can see somehow the derivative of 3 sin x is somehow 3 cos x, and what about derivative of let's say x cos x? So if I think of x cos x minus 3 sin x derivative, which was to be taught in the beginning itself, and use forceful integration by parts, so x will give 1, so cos x, it's minus x sin x, and it's minus 3 cos x, and that's a good point because it evaluates to minus 2 cos x and minus x sin x. So by taking minus common, we got exactly same expression as is demanded in the problem over there, right? So with this motivation, and we can probably take, like x cos x minus 3 sin x as t, and that will develop this part. So that gives me to our surprise integral of 2 cos x plus x sin x divided by x cos x minus 3 sin x whole square is kind of perfect differential, and then I'll multiply with this remaining guy x sin x plus 3 cos x. Fine. Now how to handle this stuff? Well, now I can do integration by parts. So we'll leave x sin x plus 3 cos x, and we'll integrate this stuff. So clearly if I'm calling this down stuff as t, this is t square, so above is going to be minus dt, right? And then minus times of this integration, and that integration is nothing but simply 1 by t. So this amounts to 1 by x cos x minus 3 sin x, this quantity. So here only I'm writing, so we will get this divided by x cos x minus 3 sin x. Now what about the remaining part? So this part simply goes away, right? Now remaining part tells me to differentiate x sin x plus 3 cos x, which is x cos x, and plus sin x if I leave, and is minus 3 sin x, and the integration of that. So integration of that in a way is divided by 3 sin x minus x cos x. Okay, and a plus will come because minus minus will become plus. And now if we'll notice the numerator, it's x cos x, sin x minus 3 sin x goes to minus sin 2x. So it's minus 2 sin x. And something remarkable happened, because this is exactly what our I1 was. I1 was x cos x minus 2 sin x by something. And we have again x cos x minus 2 sin x by something, right? And what we wanted is this I1 plus I2 into picture. So now I got I2 equals this quantity, and exactly x cos x minus 2 sin x by this, x cos x minus 3 sin x. Okay, so if I'll take minus common over here, and I replace this with negative sign, which gives me x cos x minus 3 sin x. So यहाँ से the final answer that I'm gonna get is this is I1, and I wanted I2 plus I1, and that is nothing but this is the answer to our problem. Set x sin x plus 3 cos x divided by x cos x minus 3 sin x plus constant. So I hope you have enjoyed the method, of course. But the major drawback of this method was the motivation behind, factorizing this number, factorizing this expression as determinant, and then very smartly recognizing like x cos x minus 3 sin x will come into picture. So now the original question will be like how we are gonna do about this, like how I'm going to get, that's the actual motivation, right? So here probably we can, method 2 will be the more natural way of thinking for this problem. Would be possibly to think of a function, because x square by 20 by x sin x plus 5 cos x is there, and its integration is axis, means I'm thinking for some kind of function whose derivative x sin x plus cos x, and let's say this function some p of x, such that if I differentiate this guy, I must be able to get this back, right? So why not we can start differentiating this kind of reverse engineering. So that gives me x sine plus 5 cos into p dash of x minus p of x, u v rule, x division of u by v rule, minus 4 sin x by denominator whole square, 5 cos x whole square, right? And that somewhere gives you a very exciting surprise, because here what we can do is we can try to balance LHS and RHS, because that has to be equal to x square plus 20 by x plus 5x whole square, right? That was the question, whole square. Now if we'll try to compare and set it, so clearly this goes, and now clearly there is no sine and cos in the picture for x square plus 20. So what to do about this? Since denominator is equal, we only need to seek px so that numerators are equal, right? So this quantity should be equal to x square plus 20. Okay, so there is no sine and cos over here. So what we have to do? Oh, well, fine. So if I don't want any sine and cos in the numerator or in the LHS, so somewhere it gives an indication of writing 1 as sine square x plus cos square x, right? But that's the way to invite naturally sine and cos into picture. Okay. So if I'll write either x square plus 20 into sine square x plus cos square x, or you can see the coefficient of x if I'll look over here, because x square will produce with x into something. So the coefficient of x, if I gather, is x sin x p dash x minus x cos x p of x, and the remaining coefficients is 5 cos p dash x plus 4p of x sine of x equals x square plus 20, right? So possibly if I'll take x common out of here, so let me take full x out of this expression. So there is some hope, like maybe I have to select px in such a fashion so that it can give birth to x squared too. right? So now we need to develop a systematic approach so as to get that. And hence what I'm doing is to write x square as x square sin square x plus cos square x plus 40. So now it follows that px is going to be something like minus x cos x and plus some other function q of x. Right? The reason being, this motivates me because I know, like p dash x, if I'll see the derivative of sin x is present over here and derivative of px is present over here, right? Similarly, sin x derivative is present over here and px derivative present here. Only in 5 and 4 is the missing link. So somewhere this missing connection is being bridged out by those gap. And if you put that x cos x minus plus qx, and now if I plug this expression over here, and by equating, we can see, just you plug this, you'll get an expression in qx, and there you can easily see you'll get some 5 sin x. Again, plus something left over. So I'm calling function left over L of x. If you put it back, that L of x will become 0. So I think like it's clearly not an objective examination question where this kind of manipulation will be extremely difficult, but still, if done in a systematic way, okay, with basic manipulation and with the hope that there exists a beautiful answer of this, clearly it can be done. Right? So with Lx 0 and the integration directly now plugging back, you'll get minus x cos x plus sin x divided by x sin x plus 5 cos x. So that was something really, like nice about this integral. The other way of thinking probably is the way we usually think forcefully. Again, I'll not tell it will be a very natural solution, but somehow maybe we can multiply the denominator with x to the power something n, because x sin x plus cos x, I have told it will give a motivation for its derivative. So its derivative is going to be x cos x plus sin x and minus 5 sin x. So we are getting derivative of x cos x minus 4 sin x into picture, right? So one way of linking 20 with 5 can be possibly, what if I, so it's just a thought process. What if I bring 5x4, because its derivative is going to produce 20 and of course x cube. So it's very, like no hope motivation almost, but still maybe something can be done about it. So let's try. Well, so what we'll do is I'm going to multiply this denominator by x to the power 4, that makes it x to the power 5 sin x, and plus 5x to the power 4 cos x to the whole square. Remember, I made x to the power 4, so it's x to the power 8. So I have to divide by x to the power 8, right? So it's x square plus 20 and divided by x to the power 8. So no such benefit, because anyway, if I'm going to take this as t, no way it's gonna produce that rate. So this motivation still goes away. So I think we are done with the problem, because in the first method that was possibly a better way to track this question, right? In general you can tell exactly with the determinant technique, it can be told is integration of x square plus n times of n minus 1 divided by x cos x minus n sin x whole square dx will give x sin x plus n cos x divided by x cos x and minus n sin x plus constant. So this is, like a very technical manipulation which will come from it. And this is what I was telling as of now. Like even if multiplying x power 4 does not give a nice denominator, but still it motivates me from the generalized version. Because a way of bringing n into n minus 1 is probably here establishing x to the power n minus 1 into picture. So what I was trying to do is, what if I multiply this denominator out of a motivation of like multiplying x to the power n minus 2, because if I'll bring n into x to the power n minus 1, its derivative can produce n minus 1. Okay, so let's multiply with x to the power n minus 1, so that gives x power n cos x minus n times x power n minus 1 and sin x, right, this whole square. And since I multiply with x to the power n minus 1, so I'll multiply numerator also is 2n minus 2, so that becomes x power 2n and plus x power n minus 1 times n into n minus 1. Okay, so let's see if we gain anything out of this. It's basically here we have given up because I multiply with x to the power 4, so here it will also get multiplied with x to the power 4. So that will give x to the power 10 in fact, plus 20 x to the power 8. And instead of giving up, we could have differentiated the numerator. So x to the power 5 sine plus 5x to the power 4 cos, probably we could have differentiated, and let's try. So we'll get x to the power 5 cos and plus 5x4 sine, and we have minus 5x4 cos, and that feels crazy, plus 20x cube cos. So that got simply kicked away, and we have cos times x5 plus 20x cube. Well, that's not a bad news because it's quite connected with x to the power 10 plus 20x8 x to the power 5 plus 20x cube, and that's the motivation for this. Because here if I'll take this entire stuff as some t, so dt by dx is gonna be x to the power n minus sin x plus n times n minus 1 cos x into x to the power n nx n minus 1, sorry. So that's cos x into nx n minus 1 minus nx n minus 1 cos x will have minus n times of n minus 1 x to the power n minus 2 sin x. And very interestingly, you can see these two terms goes away, and we have minus sin x out, and we'll be having x to the power n plus x to the power n minus 2 and into n minus 1, right? So that's not a bad deal because we are quite close probably. We are quite close probably in the sense like now just I need to multiply and divide by this expression. Right? So if I multiply divide by sin x and use integration by parts, it will directly fetch this result. So that was a very lame trick of using this, but still, if you will multiply with x to the power n, things is going to work. So I hope you have enjoyed this session and the idea behind solving this